Okay, so in this last video, I'm just going to summarize the concept of method of partial fractions. So remember, when do we use partial fractions? When our integrand or the expression that we have to integrate is in the form of a rational function or rational expression where the degree of the numerator is smaller than the degree of the denominator, and the denominator can be factored in three cases we discussed as a distinct linear factors or repeating linear factors or quadratic factors. And now we can have a mixture of repeating linear factors and quadratic factors. The fourth case that we are not doing here is repeating quadratic factors, because the only reason we are not doing it here is it's more lengthy, but the idea is the same and the method is again going to be kind of same, but you will not get a question like that here. So three cases and a mixture of these cases, you should be able to figure out how to set the partial fraction. So what is the method when we get an expression like that, a rational expression with numerator having degree smaller than the denominator? So if the denominator can be factored, that's what you should do. That's the first thing to do, that you should factor the denominator. Then you should set up the partial fractions based on the type of factors in the denominator, okay? Or in other words, based on the cases. Then the next step is to determine the coefficients of the partial fractions, okay? And the next thing is you will set up the integral as a sum of integrals of these partial fractions, and then you will integrate using your methods learned. Notice when you have linear factors of something like this, or remember that you could also have linear factors of the form. So for example, you could have something like 2x minus 1 in the numerator, or let's say you have x minus 1 in the numerator and 2x plus 1 times 3x minus 1 in the denominator. Then again, because the denominator are still linear factors, so you will write it as this plus that. And then if there are three factors, then you will write it like this, and then if there are more, you will keep on adding. Now, if I mentioned this before, but here I'm putting it again. So if you have a repeating factor which is repeated 3 times, now notice I have also put 2 other linear factors which are different from this repeating one. So then you will have a over this first linear factor, and you can say plus b over this linear factor, and then start writing the 3 factors, 3 expressions or 3 rational expressions which will be coming because of this. Or write it like I have done. So first one, a over the first linear factor plus, now I'm going to write the 3 fractions which are going to come because of the repetition of x minus b. And x minus b is being repeated 3 times, so I have 3 fractions for that. And then plus the last one for the last factor. And if you have a situation like this, if you have 2 factors which are being repeated, let's say twice, one of them could be 3 times or 4 times, of course, then your number of expressions that you add increases. So you will have one factor or one fraction for this, which is a over x minus a. Then you will have 2 fractions for that. So I have the b over x minus b plus c over x minus b whole square. And then you will have 2 fractions for this, which I have over here. Now we did do an example where we had one linear factor and one quadratic factor in the denominator. So then we write it like that, a over the linear factor plus a linear expression, so bx plus c over the quadratic factor. Or we could have two quadratic factors. So if we have two quadratic factors, then you will write them as a linear factor divided by the first quadratic factor plus another linear factor divided by the second quadratic factor. Now if you have, for example, x cubed plus 1 over x squared times x minus 1 plus, times 4x squared plus 1, and then maybe x squared plus 9. So you can see there will be, so let's count how many fractions will be in our expansion or in our, so 2 from here, 1 from here, 1 from here, and 1 from here. So how will you write them? You will say a over x plus b over x squared plus, so these are for the first one, and then next one is also a linear factor, so c over x minus 1 plus, now next one is a quadratic factor, so we will have dx plus e over 4x squared plus 1 plus fx plus g over x squared plus 9. So you have 1, 2, 3, 4, 5, 6, 7 coefficients which you have to figure out the values and then go from there. So this is how we do partial fractions. So these are lengthy problems, but something you can do. A lot of algebra involved in here, and of course calculus 1 involved, and a little bit of calc 2.